Good morning, my dear students. Today we are going to solve October-November 2017 2-1 paper. It's Physics 5054 course. It's paper 2. So let's start. On your screen, you can see today we are going to solve the section A of this paper. Section B of this paper we will solve in another video. Question 1 is on your screen. Figure 1.1 shows a painter standing on a wooden plank directly above the right-hand support. The plank has a length 3.6 meter, width 0.35 meter, and thickness 0.025 meter. The gravitational field strength G is 10 Newton per kg, and the mass of the plank is 23 kg. The question number 1 is calculate the density of the wood from which the plank is made. Okay. Now you see the question is calculate the density of the plank. For calculating the density of any material, I need two things. One, I need to know what is the mass of that thing. Here we are talking about the planks. The mass of the plank is given in the question. It is 23 kg. And the volume of the plank, the second thing which we need to know is the volume of the plank. The dimensions of the plank are given. The length is 3.6 meter, the width is 0.35 meter, and the thickness is 0.025 meter. So we can calculate the volume of the plank. And once we have the volume and the mass of the plank, then we can apply the formula density is equals to mass divided by volume, and we will be able to calculate the density of the plank. Okay, I have done this A part on a paper. Let me show you. It's a 2-mark question. Let me show you that. Okay, on your screen, I hope you can see question number 1A part. Volume is equals to length into width into height. 3.6 into 0.35 into 0.025. The answer will be 0.0315 meter cube. The mass is given 23 kg. Apply the formula of the density. That density is equals to mass divided by volume. 23 divided by 0.0315, and the answer will be 730.16 kg per meter cube. It's a 2 marks numerical. I hope you have understood it. Okay, students, we are going to the next question. He says the center of the mass of the plank is in the middle of the plank at a distance of 1.3 meter from each of the supports. Calculate the weight of the plank. This is first part of the B is simple. He wants you to find out the weight of the plank. The mass of the plank is 23 kg. So very easily we can find its weight. The formula for the weight is W is equals to mg, where m is 23 kg and the g value is 10. And by applying that formula, you can get the weight. On your screen, you can see B first part, W is equals to mg equals 26. Sorry, the weight of the plank was 26. 26 into 10, the answer will be 260 Newton. I, by mistake, said 23 kg. It was 26 kg. I hope you understand this part. Okay, the second part is the moment of the plank about the right-hand support. So now we know the weight of the plank. The moment of the plank about the right-hand support. Let me show you that diagram. You see, this is the center of the mass. Here, the weight of the plank is acting, and it is acting downward. If this is the right-hand support, if this is the pivot, his question is how much turning effect or the moment is being produced by the weight. So the formula is weight and its perpendicular distance from the pivot. So the perpendicular distance from the pivot is 1.3 meter, and that weight is 260 Newton. And you know the formula for the moment is force multiply perpendicular distance. The force is the weight of the plank, that is 260 Newton, and the perpendicular distance from the pivot is 1.3 meter. So simply multiply them, you will get the answer. I have done this on the paper. On your screen, can you see B second part? Moment is equals to F into D equals to 260 into 1.3. and the answer will be 338 Newton meter, so approximately 300 Newton meter. Because the data was it was a 2-mark question, so I hope that you have understood it. Okay, so we are moving to the next question. Question number C part of this question. On your screen, you can see it says, let me increase the size. Yeah, the painter moves further to the right along the plank, and the plank rotates about the right hand support. Explain why the plank rotates. Let me show you that diagram. This is the figure 1.1. You know that the painter is standing on the plank, and it is right above the pivot or support, which is on the right side. So this boy has weight, but the line of action of the weight is passing through this support. The line of action of the weight of this painter is passing through this pivot. And when the line of action of a force passes through the pivot, that force do not produce any moment. It do not produce any kind of turning effect. The reason is because its moment arm is zero. But he says that this painter stepped a little towards the right. So if this painter will move a little towards right, for example, he comes and stand here, then his line of action of the weight, then the line of action of his weight will be no more passing through this support. Then the line of action of his weight will be no more passing through the pivot. So now his weight will produce or induce moment. If we talk about the right hand support, if the boy comes stands here, now it will have some moment arm, and due to that moment arm, now the weight of this painter will also produce a turning effect in the clockwise direction. The plank in the first situation was in equilibrium, but when the painter will move to the right, and due to his weight, turning effect will be produced, clockwise turning effect will be produced, the balance of the plank will be disturbed, it will be no more in the balance, and the plank will rotate to the right, or it will rotate in clockwise manner about the right support. I have written this answer also. Let me, this is the question. I have written this answer also. Let me show you that answer. On your screen, you can see question number 1C part. When painter move towards right on plank, his weight produces a clockwise moment which disturbs the equilibrium of plank, and it will tilt towards right. It's a 1-mark question. I hope you have understood. Okay, students, we are moving to next question, which is question number 2 on your screen. Figure 2.1 shows a can of compressed air that is being used to blow dust off a computer keyboard. The pressure of the air inside the can is greater than the pressure of the atmosphere. State what is meant by the term pressure. Pressure means the force per unit area on a surface. The pressure is force acting on unit area of a surface. The ratio of the force and the area is called pressure. I have written this. Let me show you. Question number 2 on your screen. Pressure is a force acting on per unit area of surface. It's a 1-mark question. I hope you will not forget it. Okay, let's move to the next part. BA second part. Question number 2A second part is on your screen. Explain in terms of molecules why the pressure of the air inside the can decreases as it is used. He's talking about it's a 3 mark question. He's talking about this can. It has compressed air. When you use it, the air comes out of this nozzle. So when the air comes out of this nozzle, the mass of the air or number of molecules of the air which are left inside the can, they decrease because some of the air has come out of the can. So the number of the molecules of air inside the can has decreased. Technically, we say that the number of molecules of the air per unit volume inside the can has decreased. When the number of molecules per unit volume in the can decreases, so because now less number of molecules are available, so the collision number of collisions happening on unit area, that also decreases. So due to this reason, less force is being exerted on unit area. So the pressure of the gas inside the can decreases. So it's a 3 mark question. I have also written this, explain in terms of molecules why the pressure of the air inside the can decreases as it is used. Let me read the answer also. Okay, on your screen you can see the answer is second part. When can is used, air molecules come out of can. So number of air molecules in the can decreases. Now there are less number of molecules per unit volume inside the can. The frequency of collision of air molecules with walls of can decreases. Due to this, less force is exerted per unit area on the walls of can. It's a 3 mark question. Very important description. I hope you have understood it and you will also remember this description. Okay, so students, we are moving to the next part. This is the B part. He says a student uses an inverted measuring cylinder in a water trough to measure the volume that the air occupies at atmospheric pressure. Figure 2.2 shows the equipment. So initially, the inverted cylinder is full of water. This inverted cylinder was full of water. The student presses the top of the can and air passes through the rubber tubing into the inverted measuring cylinder. The air gradually replaces the water in the cylinder until no more air can leave the can. The final temperature of the air is equal to its initial temperature. You see, he's talking about the volume and the pressure of the gas, and the most important sentence is this: the final temperature of the air is equal to its initial temperature, so the temperature is constant. Okay, on your screen we have the rest of the question. The volume of the air inside the can is 1.8 expo minus 4 meter cube. The student observed that at an atmospheric pressure of 1 expo 5 Pascal, the total volume of the air in the measuring cylinder, the can, and tubing is now 9.4 expo minus 4 meter cube. Determine the original pressure of the air in the can. When he's talking about the pressure of the gas and the temperature is constant, so you remember we can apply the formula P1 V1 equals to P2 V2. Here, the V1 is given, the P1 is question, the P2 is given, and the V2 is also given. It's a 2 mark numerical. I have solved it already on a paper. Let me show you on your screen. Can you see that? Question number 2B part. And it says P1 V1 is equals to P2 V2. P1 into 1.8 expo minus 4 is equals to 1.0 expo 5 into 9.4 expo minus 4. And the final answer will be 5.2 expo 5 Pascal. So it's a 2 marks numerical. I hope the calculation, the story, everything is clear to you. Okay, so let's move to the next question. The next question on your screen is question number 3. Unwanted gold jewelry is heated in a furnace until it melts. Figure 3.1 shows the liquid gold being poured into a mold to make a gold bar. The melting point of gold is 1100 degrees centigrade. State 2 ways in which the molecular structure of gold at 1200 degrees centigrade differs from its structure at 1000 degrees centigrade. Let me reduce the size a little bit so the thing is clear to you. Okay, so he's asking a very simple question. Actually, he's asking what is the difference between solid gold and the liquid gold. He's asking you to give state two ways in which the solid gold differs from the molten liquid gold. But he has not written the question in a simple way. He has asked you what is the difference, state two ways in which the molecular structure of gold at 1200 degrees centigrade differs from its structure at 1000 degrees centigrade. This is the most important point in this question. You know, the melting point of the gold is given 1100 degrees centigrade. So the gold which is at 1000 degrees centigrade is in solid form, and the gold which is at 1200 degrees centigrade, it will be in the molten or liquid form. So this is the big trick in this the statement of the question. The rest of the question is is the all-time famous question that what is the difference between the molecular structure of a solid and liquid, or liquid and solid. So I have written this answer. You have to state two differences. Okay. Question number 3, A part is answer is on your screen. You can see. I hope you can see it. A regular arrangement of gold molecules at 1200 degrees centigrade. So I am writing the property of the molten gold, liquid gold. And the second difference is intermolecular distances are greater in the gold at 1200 degrees centigrade as compared to the gold at 1000 degrees centigrade. So it was a simple question, but the statement of the question was such that it can confuse you. I hope that you have understood it. Sorry. Okay, on your screen, question number 3, and its B part is on your screen. In the furnace, 0.84 kg of solid gold reaches its melting point. The furnace continues to supply thermal energy, and after a short time, all the gold melts. Explain in terms of molecules why thermal energy is needed to melt the gold. It's a famous academic question that when something is at its melting point, but to melt the thing, you still have to provide the energy, and when you provide that energy, the temperature of the thing do not change. Only the melting take place. We call that heat latent heat. So for what purpose that latent heat is used? This is the question. It's a 2 mark question. And you know the latent heat, or you can say the heat during the melting at the melting point, for what it is used. It is used to overcome the intermolecular forces. It is used to break the intermolecular bonds. It is used to move the molecules of the gold away from each other. I have written this answer also on a paper. Energy is needed to melt at the melting point because energy is used to overcome intermolecular forces, break intermolecular bonds, and move gold molecules away from each other. This is a 2 mark question. I hope it is clear to you. Okay, next question on your screen is the second part. The specific latent heat of fusion of gold is 64 kilojoules per kg. Calculate the thermal energy supplied to melt all the gold. So the mass of the gold is given to us 0.84. Okay, the heat which is required to melt gold at its melting point, we can find that heat. The formula for that heat is equal to M multiply L. where M is the mass of the gold which is to be melted, and L is the specific latent heat of the gold. The specific latent heat of the fusion of the gold is given 64 kilojoules per kg. So put simply these values and the answer will be in kilojoules. Okay, I have done this in, I hope you can see this numerical on your screen. This is B second part. Heat is equals to M multiply L equals to 0.84 multiply 64. And remember that 64 is in kilojoules. So the answer will be 53.76 kilojoules, which is approximately 54 kilojoules. So it's a 2 marks numerical. I hope that it is clear to you and you have understood it. Okay, students, we are moving to next question. This is question number 4 on your screen. Figure 4.1 shows a mercury in glass thermometer made using a glass capillary tube. Describe how to check that 100 degree centigrade mark is in the correct position on the thermometer. You see here on the thermometer we have a 100 degree centigrade mark. So the task given to us is to check that if this 100 degree centigrade mark is correctly placed or not. It's a very simple uh, task. What you will do, you will take this thermometer and you will hang it with the help of a stand above a beaker which has boiling water. And from that boiling water, the steam will be coming out. And we believe that that stream will be at 100 degrees centigrade. Then note down that the thread of the mercury, when you will hang it in the stream, it will go up. If the thread of the mercury becomes steady, coinciding with the 100 degree centigrade mark on the thermometer, it will show that the 100 degree centigrade mark is on the correct position. If that thread of the mercury remains below that 100 degree centigrade mark on the thermometer, or it goes above that 100 degree centigrade mark on the thermometer when you put it in the stream of the boiling water, then it will show that the mark was not correctly placed. I have written this answer also on a paper. Let me show you that. Okay, question number 4, A part is on your screen. With help of a stand, hang mercury thermometer above a beaker which contains boiling water. Make sure that the atmospheric pressure is 1 atmosphere. If the thread of mercury becomes steady with the position coinciding with 100 degrees centigrade mark on thermometer, it will show the thermometer was correctly marked for the steam point. It's a 3-mark question. A little bit tricky thing. He has not straightforward asked question that mark the steam point. He gave a trick in it. I hope it is clear to you. Let's move to the next part of this question. Okay, on your screen, the B part of question number 4. Yeah, it's a 2-mark question. Some thermometers contain ethanol instead of mercury. A second glass capillary tube is identical to the tube in figure 4.1, except that it has no markings on the glass. This tube is used to make an ethanol in glass thermometer. The volume of the ethanol in this thermometer is equals to the volume of the mercury in the thermometer in figure 4.1. The thermal expansion of ethanol is more than that of mercury. State and explain how the maximum possible range of ethanol in glass thermometer differs from the range of the thermometer in figure 4.1. Okay, so we have a second thermometer, and in that second thermometer we have it is exactly same, its size, its length, the bore of the capillary, the size of the bulb is same as that of the first thermometer. There is one difference. It is filled with the ethanol. The amount of the ethanol in the second thermometer and the amount of the mercury in the first thermometer, they are also equal to each other. But the ethanol expands more as compared to the mercury if they are given the same rise of temperature. So his question is how the range of the second thermometer will be different from the first one. Because the ethanol expands more for a certain, for if it's given at the same rise of temperature as compared to the mercury. So what will happen? The ethanol will reach the end of the thermometer at a lower temperature as compared to the mercury thermometer. In the ethanol thermometer, the thread of the ethanol will reach to the end of the thermometer at a lower temperature as compared to mercury in glass thermometer. The reason is because the ethanol is expanding more as compared to mercury. So the range of the ethanol in glass thermometer will be less as compared to mercury in glass thermometer. It's a two-mark question. Let me read you my answer. I have also written this answer. Okay, the B part is on your question number 4. B part is on your screen. Range of ethanol in glass thermometer will be less than that of mercury in glass thermometer. As ethanol expands more than mercury, ethanol will reach end of thermometer capillary at a lower temperature than mercury. I hope you have understood this. Okay, so now we are moving to next question, which is question number 5. Okay, so very easy question he's asking. He's asking you to find, he's asking you explain what is meant by ultrasound. Some medical process involves the use of ultrasound. His question is, what is meant by the ultrasound? Ultrasounds are sound waves. They are longitudinal waves. They are sound waves, but they are not audible to human. They are inaudible to human. The reason is that ultrasounds have frequency more than 20,000 hertz. So ultrasounds are sound waves with frequency more than 20,000. I have written this also. Question of 5A part on your screen. Ultrasounds are sound waves which are inaudible to human. Frequency of ultrasound is more than 20,000 hertz. So this is question number 5A part. It's a 2-mark question, a very famous question. It comes many times in papers that what is ultrasound? Okay, next question. Explain briefly how ultrasound is used in prenatal scanning. It's a 3-mark question. You must have heard that the ultrasound is used in the prenatal scanning. Let me read this answer to you. It's academic textbook question. Ultrasound pulses are sent into the womb of a pregnant woman via a transmitter. By measuring the time taken for the ultrasound pulses to be reflected, the depth of the reflecting surface within the womb can be derived and an image formed on a screen. It's a 3-mark question. I hope you have understood it. Okay, now we are moving to question number 6. Question number 6 has either or. The either or is that with this question we have been given another option. The reason is the other option, the portion which is in or section, that is from electronics, and it is in your syllabus that whenever the electronic question will come in paper, it will be always the choice of students. You will be given an option. You want to attempt this, the first portion of the question 6, or you want to attempt the second portion of the question number 6. So, but we will, in this video, we will do both the parts. Question number 6 is either the main part of a cathode ray oscilloscope consists of a glass tube. At one end of the tube, electrons are emitted by a hot metal filament. We call this process, thermonic emission. A part is state 2 requirement for there to be a continuous flow of electrons in the tube. So when the electrons are generated by thermonic emission, now we want its beam or its electrons to go straight to the screen. We want electrons to accelerate and reach the screen of the CRO. For this purpose, we have done two arrangements. One is an anode. Anode means a positive terminal of the battery. Electrode, which is anode, positive terminal, is provided there, and that anode is at very, very high voltage. So because electrons are negative, so they are attracted to that positive anode, and so the electrons accelerate. So to accelerate them, to make sure that there is a continuous flow of electrons, so we provide a anode there. And the second arrangement we make is we provide a very low gas pressure inside the CRO tube, or we create perfect vacuum inside the CRO tube, so that the flow of electron is not hindered when the electrons, if the electrons will collide with the air molecules present in the CRO, their path will be hindered. They will lose their kinetic energy. They will not be able to reach the screen. I have written this answer also. Let me show you that. Okay, anode at a very high voltage, and the second is vacuum in the CRO. It's a 2-mark question. Very easy. Okay, we are moving to the B part of this question. A microphone detects 2 pulses of sound. The output is displayed on the screen of an oscilloscope. Figure 6.1 shows how the voltage output of the microphone varies with time. Let me show you. Describe how the time between the 2 pulses can be determined using the display on the screen of the oscilloscope. This is a display on the CRO screen between the pulses, 2 sound pulses recorded by a microphone. So if you want to find out the time lapse between these 2 pulses, the method is very simple. Check how much squares horizontally. Check horizontally how many squares are between this pulse and this pulse. So from the screen of the CRO, count horizontally how many squares are there between the first pulse and the second pulse. Once you have counted the number of squares, then multiply that number with the time base setting, and the answer will be the time lapse between the 2 pulses. It's very simple. It's a 2-mark question. I have written this answer also on the paper. This is on your screen right now. From screen of CRO, count squares horizontally between both pulses and multiply number of squares with time base setting. It's a 2-mark question. I hope you have understood. Okay, we are moving to the next part. This is the OR part. This OR part means this is from electronics, and this is in the option. You could do the question 6, which we have already done, or you can do this. This belongs to the the electronics topic. Okay, the first question is, many electronic and digital circuits include logic gates. The NAND gate is a type of logic gate. In the space below, draw the circuit symbol for NAND gate. Remember one thing, that NAND gate is a combination of AND gate and NOT gate. So we have AND gate, and then we have NOT gate. So together they form NAND gate. AND gate connected with NOT gate. So its electronic symbol, circuit symbol is simple. On your diagram, on your screen, you can see, I hope you can see. Let me increase the size. Okay. This diagram, the first diagram which I draw here, this first is AND gate, and its output is connected to a NOT gate. We can use this symbol, and this is the universal symbol used for the NAND gate. Here you have drawn a AND gate, and then you draw a small circle here, and then a line which shows that whatever the output of the AND gate is, it is reversed. So this is the NAND gate's circuit symbol. This is also being used. This is also used, and but the most famous is this one, in which we have shown a NAND gate. Remember this diagram. Okay, so dear students, we are moving to the next part. He says energy supplied to LED by no, the two input terminals of a NAND gate are connected to zero voltage logic state O, and no energy is supplied to these terminals. The output of NAND gate is connected to an LED light emitting diode. The output is not zero, it has logic state 1, and LED is glowing brightly. Energy is supplied to the LED by the NAND gate state where this energy comes. So you see, it has not shown here, but the NAND gate is connected to a battery, EMF source, and from there the electric energy, it's getting the energy from there, that source. So one more question. I've written its answer also. NAND gate is connected to a battery. Okay, next part is complete the truth table for a NAND gate. Okay, if you want to do this, I can show you this. Let me show you the truth table. Reduce the size. Okay. Truth table for the NAND gate. You know, NAND gate is like you multiply them. AND gate is like multiplying. In the Boolean algebra, it's like multiplying. And whatever the answer you get, then you invert the answer. For example, if I multiply 0 and 0, the answer will be 0. Invert it, the answer will be 1. So I will write 1 here. Multiply 0 and 1, the answer will be 0. Invert it, the answer will be 1. 1 multiply 0, the answer will be 0. Invert it, and the answer will be 1. 1 multiply 1, the answer will be 1. Invert it, and the answer will be 0. So this is how we write the truth table. You see here, I have done this. 0 multiply 0, the answer is 0. Invert it. Invert means to reverse the answer. Invert it, the answer will be 1. 0 multiply 1, the answer will be 0. The invert it, the answer will be 1. 1 multiply 0, the answer will be 0. Invert it, and the answer will be 1. 1 multiply 1, the answer will be 1. And you invert it, and the answer will be 0. So this is how you write the truth table of the NAND gate. I hope it's clear to you. Okay, dear students, let me reduce the size, 150. Okay, we are moving to the next question. An electric circuit consists of a battery, a variable resistor, and connecting wires. Section PQ and QR of the connecting wires are in a region of space where there is a uniform magnetic field. In figure 7.1, the shaded area represents the magnetic field. So you can see, if you look at this diagram, in this diagram, the magnetic field is into the page. The magnetic field is represented with the crosses, and because the magnetic field is represented with the crosses, it means that the magnetic field is into the page. So what we will do, by I can determine the direction of the force on the PQ wire, and I can also determine the direction of the force on the QR wire. For this purpose, we have left hand rule. Left hand rule is that take your left hand, take your left hand, stretch the fingers in such a way the thumb, index finger, and the middle finger, they are perpendicular to each other. Stretch these three fingers in such a way that they are perpendicular to each other, like I have done. This is my left hand. Now, the thumb is F, this index finger is M, C. F, M, C. Force, magnetic field, current. Okay, because the current is into, because the magnetic field is into the current, this middle finger is in the direction of the current in the PQ. My thumb is pointing upward. It means that the PQ wire will experience a force which we call motor effect. The PQ, which is a current carrying conductor, will experience a force in the upward direction to the top of the way. It will experience a force towards the top of the page. Okay, now consider the QR side. The current is coming from the positive of the batteries. From the QR, the current will be going towards the bottom of the page. So use the left hand rule. Stretch your fingers, F, M, C. Magnetic field is into the page. The current is going downward. My thumb is pointing to the right of the screen. My thumb is pointing towards the right of the right side of the page. So the QR will experience motor effect. The QR is a current carrying conductor in a magnetic field. It will experience a force towards the right of the page. Okay, let's move to the question I was explaining to you. The direction of the magnetic field is into the page. A current carrying wire in a magnetic field can experience a force. In the table, mark one tick in each column to indicate the force on the PQ and the force on the QR. Okay, the force, because from positive the current is coming, on the PQ, you know the magnetic field is into the page. The current is going from P to Q. My thumb is pointing towards the top of the page, so it will experience a force towards the top of the page. And in the QR, the current is going downwards from Q to R. Magnetic field is into the page, and my thumb is pointing towards the right of the. So for the PQ, I will put a tick here, a force towards the top of the page. For the PQ, we will put a tick in this portion, a force towards the top of the page. For the QR, we will put a tick here, a force towards the right of the page. It's a 2-mark question. I hope I have tried that I can give you the detail that how we find that direction by using the left hand rule. I hope you have understood. Okay, so he says the next B part is the battery in the circuit in the figure 7.1 is reversed. State and explain the effect of this on the PQ and the QR. If you will change that direction, if you will reverse the battery, the direction of the current in the PQ and the QR will change. The direction of the magnetic field has not changed, but the current which was flowing in the PQ and the QR has reversed. Due to that, the direction of the force will also, which was experienced by the PQ and the QR, they will also reverse. For example, the PQ was experiencing a force towards the top of the page. After the battery is reversed, the PQ will experience a force towards the bottom of the page. In the first scenario, the QR was experiencing a force towards the right side of the page. When you will reverse the battery, the direction of the current in the QR will also reverse, and the force, the motor effect experienced by the QR will also reverse. Now a force towards the left will be experienced by the QR. It's a 2 mark question. I have written its answer also. Try to write the answer. Okay, on your screen, let me reduce the size a little bit, a little more. Okay, here you on your screen you can see question number 7, A part. The PQ, a force towards the top of the page, and the QR, a force towards the right of the page. In the B part, he says when current will reverse, the direction of force on the PQ and the QR will also reverse. On PQ, direction of force will be towards bottom of the page, and the force on QR will be towards the left of the page. The 2 mark question. I hope you have understood it. And the C part is force experienced by the PQ and the QR will become smaller. Oh, we have not read this question yet. We have a C part also. He says the variable resistance adjusted and the current in the circuit decreases. So just one effect of decreasing the current. You know, the motor effect depends upon the strength of the magnetic field and amount of the current flowing through the current carrying wire. If you will decrease the current passing through the current conductor, the force experienced by that conductor will decrease. So when you will reduce the amount of current flowing through the wire PQ or the wire QR, the force which they are experiencing due to them being in the magnetic field, that force will decrease. So this is a 1 mark question. Force experienced by PQ and the QR will become smaller. I hope it's clear to you. Okay, dear students, we are moving to question number 8. A sample of radioactive isotope radon-222 decays by the emission of alpha particles. As alpha particles travel through air, the air is ionized. Describe the composition of alpha particle. You know, the alpha particles are like helium nucleus. Uh, they are purely like a nucleus which has 2 protons and 2 neutrons. They are positively charged. These are the alpha. I have written this answer. Okay, on your screen, the A part is showing. Number 8, A part, first portion. Alpha particles are like nucleus of helium. It has 2 protons and 2 neutrons. It's a 1 mark question. I hope it's clear to you. The next question is, explain how an alpha particle ionizes air. You know, alpha particle is relatively heavier, and alpha particle is positively charged. So when it passes in the air, when it travels in the air, it penetrates the air. So whatever the molecules come in contact, it is, because it is positively charged, so it has the ability to knock electrons out of air molecules. It has the ability to pull the electrons from the air molecules. So when it flows, it penetrates through the air, it ionizes the air molecules. I have written this answer. Alpha particles are positively charged. It has affinity for electrons. So when it passes through air, hello, I'm sorry. All of a sudden, the the speaker was on. Okay, so I was talking about the alpha particles are positively charged. It has affinity for electron. So when it passes through air, it pulls electron from the molecules of air. So that's why the air molecules will become ionized. It's a 2 mark question. I hope it's clear to you. Now, uh, question number 3. State how the relative ionizing effect of alpha particles compare with that of beta particles. The alpha particles are more ionizing. They have stronger ionizing power as compared to beta particles. And alpha particles also have more ionizing effect as compared to gamma rays. The next question is the half-life of radon 222 is 3.3 expo 5 seconds. The number of radon 222 atoms in the sample is 4.8 expo 4. Determine the time that it takes for the number of radon 222 atoms in this sample to decrease to 1.5 into 10 raised to power 3. Okay, so let me show you it's working. It's very simple. I need to know how many half-lives have passed, and then I know the half-life value, then I will be able to tell how much time has passed. So let me explain to you here. So the original value was 4.8 expo 4. I half it, it becomes 2.4 expo 4. Then I again half it, it becomes 1.2 expo 4. I then again half it, it becomes 6 into 10 raised to the power 3. I again half it, it becomes 3 into 10 raised to the power 3. I again half it, it becomes 1.5 expo 3. So count how many half-lives have passed from the number of atoms from here to reach this number of atoms. 1, 2, 3, 4, 5. So 5 half-lives have passed. So one half-life is 3.3 expo 5 second. So five half-lives will be 5 multiplied 3.3 expo 5. And the answer will be 1.65 expo 6 seconds. So this much time has passed. I hope you have understood this net which we draw for the half-life and then this calculation. Okay, the last part is suggest one reason why in practice the time for the number of radon 222 atoms to decrease to 1.5 into 10 raised to the power 3 may differ slightly from the value obtained in the B's first part. So the time which we just calculated, he says originally the time will be slightly different from the time you just calculated. The reason is because this is a radioactive decay, and the radioactive decay is a random process. Because it's a random process, we cannot, it do not remain constant throughout the process. It's a random process. Okay, so its answer is here I written decay is a random process. That's why the time will be slightly different. Okay, dear students, so the section A is done. Section B we will do in another video. I have tried my best. I'm sorry for the interruption of that speaker, and because I don't know that much of editing, so I'm sorry. And I have done my best to make the concepts clear for the section A of 2017 October November 21 paper. It was a theory paper. The course was Physics 5054. I hope that you have understood it and keep studying hard and striving hard. You will, your answering skills in physics will improve. Thank you very much. Have a good day and God bless you all. Thank you very